Pyramid day. Pyramid. Biggest difference between a pyramid and prisms and cylinders from yesterday. Biggest difference? Obvious difference? Maybe not, but from a pyramid, from a prism, and a cylinder from yesterday. What's up, Radhika?
The base is not parallel and congruent to the.
Well, that's impossible, right? Because how many are there?
One.
Yeah, that's all I'm looking for. One base, right? One base in a pyramid. Not two, like the prism and the cylinders, only one base. So two things I need you to know about a pyramid. First is 95% of the time, I don't want to say 100% because you never know, you might get a problem that doesn't, but the base is regular. We've gone over that term multiple times this year, so what do you know about the base then? No matter what shape it is, what do you know about it? All sides congruent, all angles congruent. Okay, the base is regular. So if you see a four-sided base, it's probably square. All right, good. Now, what about the non-bases? Non-bases, they're always going to be what? Okay, congruent. I was just looking for the shape, but that's fine.
Triangle.
They're all going to be triangles, aren't they? All going to be triangles. Let's put a little more detail to it. Non-bases are isosceles congruent triangles. Why is it good to know they're all congruent? I only need to find the area of one and then multiply it by how many of them are. Right? I don't need to find the area of each of them if they're all congruent. And then I get into a regular pyramid, which is mainly what we're going to be working with, where the base is regular. Okay, the base is regular. Here's the tough part today. Here's the tough part. There are not one, but two heights. Two heights in a pyramid. Two. Has anybody ever seen Mission Impossible?
Which one?
I don't care.
Yes.
But you're familiar with the concept, Mission Impossible, kind of what it's about. All right, because that's how I'm going to describe the first height in a pyramid, all right, which is called the altitude. All right, I don't have no idea. Let's see, you guys at home, I can't really see that. Maybe you can see me there. We'll see. All right, here's how I think of the altitude, the actual height of a pyramid. What you guys need to envision right now is you are at the top. You are at the top right here, called the apex, actually. That's called the apex. You're at the top. That's what you have to envision right now. So you are at the top of the pyramid. You have no way of getting down. No way of getting down. All right, you're just hanging there from the apex. So what you need to do, the only thing you have in your pocket is your rope. So from the apex, you drop it straight down to the center of the floor. This right here, from the apex to the center of the floor, that's your altitude, everyone. Altitude. That is the height. That is the height. All right? All good. Where the altitude comes from in a pyramid. Everybody at home, all good. From the apex, straight down to the center of the base. All good, and then you guys can obviously slide down and you're safe, right? So that's what you can envision the height or the altitude of a pyramid. All good? All right, perfect. We'll clean that up later. Oh, I'm going to keep it going. All right, so we know what the height is, the altitude. Now there's a different height, which is the slant height. That, all the faces are triangles, right? The slant height is the height on those triangular faces. So if I draw in the slant height right now, take a look. It's right there. It's the height on one of the triangular faces. That is slant height. Okay, slant height. And don't ask me why. I honestly don't know the answer to this question, but mathematicians denote it with a lowercase cursive L. Slant height. Maybe S was taken, so they went to the next letter. I don't know. All right. So there's your slant height. So you have the height, which is coming from your apex, drop your rope down, and then you have slant height. All right, two different heights. All good? We're going to use both, though, today. We are going to use both. All right, lateral area. Somebody help me out. I don't need a formula. What is the concept of lateral area we went over yesterday? Find the area of everything but the base. How many bases in a pyramid? Perfect. Take it off. What's left? Sometimes 4. Depends on the base. But triangles. Everyone know how to find the area of a triangle. There's your lateral area. Number of triangles. There it is. Number of triangles times 1/2 base times height. That's it. You only have to do it once because I already told you they're all congruent. So let's try to find the lateral area of this pyramid down here. How many triangular faces do I have? 4. And they're all going to have the same area. So 4 times 1/2. All right, let's focus on one of those bases, one of those triangular faces. Let's focus on that one right there. What's the base? Okay, 12. We got that. All right, here's where we're going to have to do a little work now. Let's get this ad stopped.
You want to go to school where remote learning can be as remote as you want.
Yeah, great. Yeah, why don't you try that? Yeah, we'll jump on some rocks later too. That sounds like a blast. Let me know how much you actually learn. Wow, that looks pretty good. Stuff in the woods, yeah. I could have my 4-year-old daughter go out and collect a freaking pine cone. Looks good. All right, here you go. We're really learning. All right, now let's talk about the height. Son of a... See, now it's coming back to bite me. You want to make fun of my outdoor learning? Okay, we're done. All right, here we go. So now I got the base of one of those triangular faces is 12. See where the 8's pointing to? Is that the height of one of those triangular faces? No, that's my Mission Impossible height. That's the altitude. What do I need? I need the slant height, don't I? That's the height I'm looking for to finish off this lateral area. And guys, do you see what's formed inside? The altitude is a leg. The slant height is the hypotenuse. Now I got to show you what's the deal with the other leg down here, this horizontal leg. It will always be half the base length. Okay? Always half the base length in a square anyway. And that's mainly what we'll be dealing with. So if the base side is 12, that side in there is going to be half of it, 6. And if you're wondering why or how that is, that's because when you drop that height of 8 feet down, it always goes to the center of the base. So that's going to be 6. How can I find slant height now? Pythagorean theorem. So I could say 8 squared plus 6 squared equals the height I'm looking for on the face. We got 100. So the slant height ends up being 10. So plug 10 in, and there's our lateral area. 240 square feet. We okay there? So all I need to do, find the area of one of the faces, multiplied by how many triangles I have. That's lateral area. Now let's go surface area. So surface area is just my lateral area. Now what am I adding back in? The only base, right? So I'm just going to put, because I don't know what the base is. It could be a square, could be an equilateral triangle, could be a hexagon. I'm not going to put it, I'm just going to put big B here. And all that's going to tell me is area of the base. Okay, that's all that's going to tell me, area of the base, because it could come in so many different shapes. All right, so now let's, same pyramid, surface area. We already did the hard part previously. That was 240. for your lateral area. Now, what am I going to add on? Don't tell me. I'm going to call on people now. What do I add on to the lateral area for this pyramid? All over the place with the tabs. Oh, 2-1. Zach, what am I going to add on? Where'd you get that from? Good. The square base, which is 12 by 12. Perfect. Whew. $260. Nope, 384. Emma, how's that look?
Good.
Great, thanks. Other questions? Just need a confirmation from you. I'm good. Anybody else? We good? All right, one doesn't make you great. Let's keep eating. All right, you're welcome for this next one because I just spoon feed you on this one. And all you have to do is find the lateral area. Oh boy. All right, who's going to help on this one? Let's go. Let's go. 7. St. John, here you go. How many triangular faces do I have? 4. 1/2. What's the base of one of those triangular faces? 10. And have the height of one of them? 13. Yep, you're welcome, everyone. Everything's done for you there. Just want to make sure we don't try to involve the Mission Impossible height. Yeah, that would be 260 square inches, right? Oh, and then we get to number 2, and then kids start freaking out. He flipped it upside down. Well, cry me a river. All right? Let's act like we're in honors. Yeah, I did flip it upside down. It's not that big of a deal. Here you go, lateral area. I still have 4 triangles. 1/2. The base looks like one of the triangular faces will be 7. Now we got to do a little work, right, for the slant height. I know my altitude of the pyramid is 7. What about the other leg? 3.5, not 7. Cut it in half, 3.5. Now I can do a little Pythagorean theorem to find the height of the triangular face. So I go down below, 3.5 squared plus 7 squared equals the old slant height squared. Square root, I get the slant height to be the square root of 61.25. You guys have known me for about 34 weeks now. Let's play a game. Guess what will Mr. Carlino say next?
It's not to the nearest 10. Oh.
I wasn't going to say that.
No.
No.
Correct! Don't round the darn thing. Are we done with the problem? I don't care that that's not to the nearest 10. Your answer better be though, Kylan, right? So leave that whole thing there. 6 square root of 61.25. No need to round yet. Now, as you crunch those numbers, 4 times 1/2 times 7 times the square root of 61.25, then you can round that number on your calc. And I have 109.6 square meters. Anybody issues at home yet? Okay, you are on your own for number 3. We'll do 4 as a class, but number 3 you're on your own. Surface area. Surface area. I'll give you a little bit of time and then I will put my work up there. Surface area now. Changing over to surface area, everybody. I wonder how many people are going to fall into the trap here. I fell into the trap, so it's okay if you do. I had one job. Okay, how we look here? 147.6, the trap I was referring to that I fell into this morning. No self-respect. Make sure you have 2.5 as the leg of the triangle, not 5. Okay, I did a little 12 squared plus 5 squared. Yeah, wrong. Still fired up about it. Anybody in class or at home, any issues here? All right, guys, I can't keep feeding you square pyramids here. I can't. I need you to be exposed to something else. And that's why I've given you number 4 to show you that, hey, the bases are not all square. How about a little hexagon action? A little hexagonal base here. All right, no problem. No need to worry. Let's start with the lateral area. How many triangles do I have now? 6 triangular faces. Again, don't get in that 4 mode. Now you have 6 times 1/2. Let's take a look at one of them right now. What's the base for one of them? 6. And you don't need to do any work because I gave you this. What's the height? 12. The slant height I gave you right there is 12. So there you go. There is the lateral area. Done. Now we got to work. Because now what we need is the area of the hexagon. Oh, good thing we did this last unit, huh? Good thing. So we got 6 meters down here. Good thing we did this. So here's our hexagon we got to find the area of. So let me just draw in one of the how many triangles I could form down there? 6. Okay, so ready? That's how I'm going to start it. 6 triangles times 1/2. We'll get to the rest in a second. All right, what was that angle I just created here? 60 degrees. 360 divided by 6, 60. The height is bisecting it. So everyone see why I have 30 here and 60 here. The height is also bisecting the side. So now across from the 30 is going to be what measure? 3. What about the side across from 60, which is probably important to me? 3 radical 3. So let's go back to the surface area formula. 6 times 1/2. Be careful here. Here's where a couple of you made a mistake on your test. What's the base length of one of those triangles? 6, not 3. Not 3. We're finding the area of this whole triangle there that we made. So 6 times, and then what did you guys just find the height was? 3 radical 3. Yep. So this right here, I'll move it back up here in a second. This is big B. That's your area of the base right there. All right. Any questions finding that area of the base? I know it can get confusing in your head because you're like, height's here, base is here. Oh, you got a lot of triangles to work with, I know. Suck it up. What am I looking at? 309 when you guys crunch them out? Meters squared.
How do you get 309? I thought 237.5.
So we have the same values?
Yeah, that whole formula at the top is the same.
I don't know what to tell you there. Sure, we're all typing the same thing. 6, 1/2, 6, 12, plus 6.
Yeah, I typed in the lateral area, so I had like 154 plus 54 radical 3.
Okay, so 216. The lateral area is 216.
Oh, that was fine.
Okay, 12 times 6 times 6 times 1/2 gives you 216. And then you do get 54 radical 3 for the area of the base. That is correct. All right, you ready to finish this on? You know how we're going to finish everything in this unit. Let's take a couple figures we're familiar with and put them together. I'll make a little house here, huh? Find the surface area. All right, we talked. I'm just gonna prep you for this, and then you're gone. All right, you're on your way. What's the bottom figure? Oh, what? Rectangular. Use your big words, okay? Rectangular prism. Usually, a rectangular prism has 6 faces. Am I gonna find the area of all 6 here? No. Only how many faces are showing? 5 faces. So you should be finding the area of 5 faces that are showing of this rectangular prism. Then you're going to add it to what's on top? A pyramid. Are you going to find the surface area of the entire pyramid? I hope not, because what's covered up? The base. So let's talk to me in vocabulary terms. You're really just finding the lateral area here. All right, let's go. Let's see what we got at the end here. All right, make sure, I had a couple people in my first period class. Make sure with those 5 faces for the rectangular prism, they do not all have the same area. 4 out of the 5 have the same area. The 5th one does not, so be careful there. Hopefully you're not doing 5 times 6 times 3, because they're not all 6 by 3. 4 of the faces are 6 by 3. The other face is the bottom one, the floor, if you want to call it. That's 6 by 6. So hopefully the rectangular prism is coming out to be 108 square feet. Give you a little time on the pyramid. 4 faces. Times 1/2. What was the base of one of those triangular faces? 6, right? Opposite sides congruent, so 6 feet. And the slant height was already drawn in, so times 4. The pyramid surface area that's showing was 48 square feet. And then now we just put it together, the total. $108 for the prism, 48 for the pyramid, 156 square feet. What's up, Radhika?
If you had an altitude instead, but
Correct.
going from the top of the pyramid to the bottom of the rectangular base, could you subtract it from like the height of that?
We would have to subtract 3 from it.
Okay.
Correct? Yep. Other questions, comments? All right, what do you say we behave this weekend? You got your quiz Thursday, Friday next week. Cone on Monday. Cones. Have a great weekend. Be smart, behave, everyone. Yeah.
When do we get our test?
I can give them to you right now. I meant to give them to you at the beginning, but I had to start out right away. Let's see, period 4. Radhika, there we go.
Yeah.
Well, thank you. These guys still on? Nope. Stop the recording.